I am officially recording this second webinar of the series, right, that Multidata is offering. These are webinars that want to discuss tools or technologies related to multimodal communication, as well as their didactic applications in higher education or somewhere else, or also their applications to society. And we have the perfect guest today for that. So I'm giving over to Raul, who is the person whom we need to thank for having Germán today with us. Okay, Raul, all yours.
Thanks. First, I'm really proud to having here Germán with us this afternoon. We know each other maybe 15, 20 years. So I know Germán since was a teenager. He was always compiling with his Gentoo Linux all the packages and talking everybody the goodies of that kind of working. But after that, he managed to finish her bachelor degree computer science with cum laude. Also, after that, his thesis in computer vision also with cum laude, has become a leading figure of the field of the computer vision and deep learning. And for me, it's an inspiration to have a person like Germán near me, because for me, it's just a person to look to. Okay, he has been working in simulation, artificial intelligence, autonomous agents, and autonomous car for years. And also we can say that you are, Germán, a passionate advocate for open source software for all your life. And you have led projects like Carla, it's an autonomous driving simulator. And as you say, an open 3D library that is really impressive. And recently you have been working in companies like Toyota and Intel, leading the autonomous Legend labs. I had to read this. And now you are serving at NVIDIA as the director of the simulator ecosystem, okay? So for me, it's really impressive, your career. I thank you a lot to being here and share your expertise with us today. And it's an honor for me to having you here. So thank you very much, Germán. So
Well,
I don't know if anyone want to add anything else, maybe Peter
just
or
just the title of the talk, and then
I
we go on.
didn't say the talk is titled "From Models to Agents: The Next AI Journey." I think it will be the topic for the 2025. You see, not this yet, and Germán for sure is going to show us all the topic and will so how will be really important for next year for us. Thank you, Germán.
Well, first of all, thank you, Raul, for your super kind words. I think you are exaggerating greatly, but thank you. And thank you for the invitation. I'm very honored to be here today. Look, it was hard to say no. Well, first because Raul asked me, and he insisted, and secondly because I own a lot. I owe a lot to the Erasmus program myself. So I love to see these activities happening in Europe, and I love like Europe, the European Union, to kind of like putting funds into creating something that can benefit many, right? Like we should not lag behind the US and China in anything related. So I think this is a great initiative. We're happy to be here today. So I'm gonna be sharing my screen. I hope this works. Oh, it works fine. Yeah, perfect. So, okay, great. Today I'm gonna be talking a lot about agents. Okay, so all of you know about AI models,
Germán,
especially.
we're seeing your presenter view, so we're seeing your notes and the slides in small. Is that what you want us to see?
No. Let's see why Zoom is doing this to me. Let's swap this place.
Typically, that looks like the right one.
Okay, great. Awesome. So what I was saying is that today I'm going to be talking about agents. Everyone is used today to see and work with models, right? That's why it's becoming very popular. Agents are a little bit more surprising, a little bit more impressive. when they work, and let's see when that is, and let's talk a little bit about that. So a little bit about me, but Raul already did the job, so I think I'm gonna skip this. Basically, my expertise is primarily in artificial intelligence for autonomous systems, right? And then I did a lot for simulation, primarily because some of the autonomous agents that I care about operate in the physical world, so it's not very let's say it's not very kind to test them in the physical world unless you're sure that they're going to work and they're not going to hurt anybody. So a lot of simulation for AI got into the mix to make sure that you can train, validate these agents properly, and they operate as expected, especially in the validation and verification side of things, making sure that, well, they are not going to react weird to any inputs. So these are typically black boxes these days, so very large neural networks or sets of neural networks. So it's very important to make sure that they're properly validated in these digital worlds and before you have them out there running. So I have done a lot of that in industry. So I was one of the pioneers in the field to suggest like we could use this virtual environment to actually train and validate AIs for different tasks, especially for those tasks that involve, complex perception and planning. And since then, I basically have been helping different companies bootstrap their capabilities in the area of autonomous systems and AI. So grown from Apple with their now defunct Titan project to General Motors, DARPA, NASA. I have the pleasure to lead several research teams at Intel, and now working more on the product side of NVIDIA, seeing how these technologies evolve into products that are in the hands of all of you. Very happy to be here. The type of agents that typically I work with look more like this, right? So I work with physical agents. Today, I'm not going to be talking about physical agents. I'm going to be talking about web agents, things that take information in, basically process and do stuff with that information. But so that you get an idea, this is what I do in daily basis. So a lot of curiosity. If you're curious about this, let me show you a quick demo. This is work that I did through my non-profit foundation in collaboration with MULTIDATA de Barcelona and Volkswagen. So basically, there is this tiny little town on the Pyrenees that I think the average age there is like around 75. So it's an age population. There's no public transportation. There's no taxi. There's no anything there. So we have the goal to create an autonomous taxi service, basically connect this little town in the mountain to the rest of the of the world. We're basically creating an end-to-end agent to this end that we train in simulation and deploy in the real world. So here you can see some examples of the deployment with a safety driver in really harsh conditions, like snow, etc. You can see that the road is very narrow, and unfortunately, on the left side of the road, there is nothing. So if you fall, there's a cliff. If you fall, you will probably. So it's important that, and you don't have this rail throughout the entire. This is just for, as you can see, for brief chunks of the road. So it's a challenging environment, but we managed to put together an agent that was able to basically navigate this perfectly fine by using a lot of simulation and by using a lot of synthetic data and end-to-end agents. So this gives you a little bit of an overview of what I do in a more of a daily basis. Now, let's talk a little bit, coming back to the main topic of the presentation. So we're going to be talking about agentic AI or agentic frameworks. As you guess, agents have been around for a while, right? You're probably familiar with the evolution of machine learning and AI from, we have all heard about the different winters, etc., from the invention of the perceptron. if we move towards the right side, toward the modern era, modern age of artificial intelligence, we've seen a lot of progress in the last 10 years, really, since the invention of AlexNet, like the introduction of deep learning in 2012. We have seen this Cambrian explosion, right? So first with very good discriminative models like CNNs, eventually the invention of the transformer architecture in 2017, follow up by the invention of the visual transformer, right? So we migrated from audio computing, etc., to other modalities. So computer vision wasn't the first one receiving the transformer, but we managed to adapt it quite successfully, I would say. And then since then, people have great intuitions, right? And say, these transformer architectures, they seem to scale quite well with data, much better than CNNs and other architectures that we have seen. How about we keep pouring data in? And this person, Ilya, Ilya was right. That was the foundation of OpenAI. More data, more scale, more compute. Let's make transformers a huge success. And that was the beginning of GPT-2, GPT-3, etc. And we know that today as ChatGPT. And since then, many things have happened. Like we have a lot of generative AI solutions coming to generate images, to generate videos. It's being popularized, brought to the users in different forms and shapes, including web chats. So we can now all talk to web chats to basically tell the agent what we need, what we want. And it's able to do a relatively good job, right? All of these thanks to compute and data. So thanks to GPUs and very large data sets in which we can do pre-training at the level of the internet. So YouTube, Wikipedia, etc. A lot of data, a lot of GPUs, and here we have very powerful machines. Now we are taking all these ideas and going the next stage, the stage of agents. Let's talk about that. I think it's very exciting. By the way, please, let's make this as interactive as possible. So if you have comments or questions during the talk, I'm a person who likes things to be interactive. Speeches are boring. So feel free to, can they unmute themselves or do they need to go through anybody to be unmuted? I guess I should have asked that at the beginning of the talk.
I think this is quite uncontrolled and chaotic, Germán. So if people
That's
really
the
want
world.
to,
That's the world I live in. So great.
exactly. So if they want to create chaos, it's not going to be too hard for them. It's just that usually the people we have over here are over polite. We're trying to make them a little nastier. Let's see if we can get to that.
Yeah, I don't deal well with politeness. I feel like itchy. So please go ahead and ask questions whenever you have questions. But yeah, I think the history of deep learning and AI is relatively straightforward. So I will not stay here for long. This is more. So let's talk about today's predominant approach. And this is something that you all know about. So in the era of large language models and also visual language models, we see a lot of zero-sum workflow, right? So where you have a task, for example, tell me what you see in this image and highlight the most relevant objects. You have a model that is going to try to do a one-shot operation, meaning like it's going to try to solve the entire operation in one shot. Sometimes it works, and when it works, it's amazing. I love it. So you will receive an output like, yeah, I can see a few things in this environment. There are cars, palm trees, a building, etc. We can see some example of this, and I have left QR code on purpose here so that you can go and check. Actually, let's check some of this. So, for example, the NVIDIA NIM Llama. Let me come out of here. So just for fun, this is I'm gonna show a little bit about NVIDIA NIM, and I'm not trying to promote any products or services that my company makes, but it's actually quite useful in this case. This is like a well-integrated, well-packaged AI model or agent for you to consume and for you to deploy if you're a developer. So in this case, this is a Llama 3.2, 90 billion vision instructions. So it's a multimodal model. It's supposed to be able to do a bunch of interesting things with images and videos. So why don't we give it a quick spin, see what it can do. Actually, same images. Tell me all the main objects in this image. Okay, let's see. This is your expected output, right? You have cars, you have palm trees, buildings, etc. There are a bunch of things that this model is not going to be able to do. It's still a model that is trying to do zero-shot operations. So really trying to come up with the whole set of actions in one go. It hasn't done a bad job, right? It told me about the different categories, but this is a little bit underwhelming. This is not what I was expecting. I was expecting bounding boxes, etc. This is not what this model is giving me. Sure, I could try to go to a different model. I could try to go to something like Villa or Cosmos, and I could try to reproduce this thing in Cosmos, which is a computer vision model. But what are the main elements in this picture? Oops. Please provide bounding boxes. Okay, let's see if I can do it. Oh, thank you. Didn't believe I'm a human. Okay. Human. Okay, this is closer to what I was expecting. A bunch of bounding boxes with certain level of success. Of course, there are a few misses far away in the image, but this is specialized. Well, why do I have to come to this question? I'm a little bit lazy. I prefer when things happen when I want them to happen, not to have like the right tool at hand. So this is what you can expect today. Look, it works relatively well. And we should all be impressed by the accuracy of these models. They're over specialized in a subset of tasks, right? So they could be more useful if we could put all of them together, correct?
So Germán,
Yeah,
once
go ahead.
we're about interactive, I
Yeah.
was wondering how far are we from all the things that humans are going to directly perceive at the speed of light, like not just object detection, but also, a human would immediately perceive viewpoint, directionality of objects, relative distances, talking about still basic things. Then I'll make it harder because we're from the human point of view here. Are we anywhere near that yet for this kind of model?
It depends on the architecture that you have in mind. I guess if you're envisioning this super large model that somehow has these emerging properties to discover, point of view, objects, mask, etc., then we're far away from that. But if you're imagining a different architecture where you have access to a set of tools, basically this becomes a very well integrated platform with very useful tools. We're not that far away from that. And that's kind of like hinting in the direction of agents. So not models that know everything ahead of time and are able to do everything ahead of time, but systems that are able to operate with different tools and that have access to a plethora of tools or can generate their own tools when needed. So you need a tool to basically tell you about the point of view of that image. You can get access to it, or perhaps you can generate it and then invoke it to get an answer.
So they can
That's
be
the
trained into
direction.
that. They get there through training, which is pretty much the way human beings or biological systems would get. I mean, you don't just see this as a newborn and understand the same thing as an adult. You need training. So that this is what you would accomplish in this way.
You need training, and then you need also the right platform with the right integration to call all these tools, etc. So let's see how this is evolving in that direction. So back to this presentation. I think I have okay. So this is a serious thought. You can get the same thing with other. Now, if we ask for something more complex, as we have experienced before, probably the model is not going to be able to produce the desired output, right? Like in a serious thought process. So if you ask for something too complex, like find all the vehicles in the image, and then for each vehicle extract their poses, and then create new images in toy cards, etc., it's too complex. The model is not going to be able to do this in one go yet. So what's the alternative? The upcoming approach, which is already in some form around us, is the agentic workflow. So the agentic workflow basically is able to do a few things. First thing is it's going to try to decompose a complex task into subtasks. So it will do something like, hey, first I'm going to analyze the image, find all the vehicles. Then I will use a pose estimation tool to extract their poses. Then after that, I'm going to call control net to condition. Yeah. So basically, it tries to create a plan, and it tries to attempt things, check what works, what doesn't work, have a critic validating what paths have been working, and basically invoke any tools that are needed, call other agents if needed, even create new tools if needed, and then come back with a solution. So this is where we are heading. I have to admit that we're not quite there yet, right? We have like very passionate and smart people creating the new platforms that are the foundations of this, right? And if you are a developer today, you can get access to those platforms and you can play with those quite well. As a user, we don't have that many user-friendly interface that allow us to just go there, present our problem, and get good solutions. I'm going to show you a few things that are moving in that direction, but still the early days. But it's getting there, and 2025 is going to be the year of agents, and we will see many new services and systems that will allow us to interact with agents in a way that is simple and effective. But 2024, Q4 2024 is a year of agents for developers. We are going to see a lot of APIs, and we are surrounded by platforms that provide APIs for you to set up your own agents. We're going to be talking a little bit about that in case someone is passionate about it. But yeah, this is where we are today. Okay, so I guess the first question that we should ask is what is an agent? If you're interested about this, Jean LeCun has a very interesting positioning paper. Jean LeCun is one of the fathers of modern AI, right? The way Jean talks about this is that an agent is an entity that can learn to reason, learn to plan, and learn a representation of the world. And this is very, very important because if the agent doesn't understand the world, everything is going to be out of whack, out of context, right? So it can learn all of these mostly by observation, with minimum interaction with the real world, just observing data. Can learn a set of plans at different levels of abstraction. It's important because sometimes you actually have a very long horizons where you have to do, you have to really plan for very complex tasks. And at the same time, each of those tasks might be composed by multiple steps. So you have these two different levels of abstraction, like short-term, short horizon, and long-term horizon. And you need to be able to do both. You need to be able to have different levels of abstractions in your plan. And you need to be able to decompose those plans in a set of actions, a sequence of actions that you can execute. So this is sort of like what is an agent as its core. And a potential architecture to achieve these agents is the one that you can see here on the screen, and it's composed by multiple parts. So if we go one by one, so we have a perception module that basically takes care of estimating the current state of the world. So these are the computer vision, language processing, and text processing capabilities that you are all familiar with, all of them put into a nice perception stack, right? Then you have an actor. This is the entity that is responsible for actually creating sequences of steps, right? So these steps are in charge of achieving a goal. They need to minimize the cost, what we call the future cost. So basically, for example, minimize the level of hunger of the robot or the agent, or maximize the happiness of the robot. So we need to define a cost that guides the entire process. We have a world model, very important. So basically this world model attempts to predict what the state of the world is going to be after you execute your plan. So how the world is going to be evolving, because when we act, the world is not static. Things happen in consequence of our actions, sometimes even independently from our actions. So you need to have a good model of what's happening out there. In this case, the world could be, what's going to happen in your database. And it's important to understand this in order to come up with good plans. So you need to understand how your plan is going to affect the world and how the world is going to be evolving in order to come up with a plan that makes sense. In order to do that, we're going to have modules that attempt to compute cost. This cost is basically scalar value typically. You can call it energy. It's basically something that attempts to describe whether discomfort of the agent, right? Like if the agent is having, is executing a plan that is going against the survival of the agent, or is trying to measure something positive for the agent, like for example, the health of the agent, the success level of the agent, etc. And typically this is composed by two parts. One part that is static, that's the intrinsic cost. Again, plug your favorite metric here. And one part that is trainable and dynamic. So like the critic. The critic is something that is a model that needs to do predictions about how the intrinsic cost is going to behave, so that we can avoid to fall in plans that are going to be against our intrinsic cost. And this is a very general architecture that attempts to kind of like position what are the different parts. Oh, by the way, sorry, I forgot like two parts. So the short-term memory, so you need to have your typical memory, so vector database, whatever works in order to keep track of what has happened in previous steps. And finally, if we want an agent that is generic enough, we probably have to tune all these different modules dynamically based on the task. So you can imagine that all these modules are generic, they have been pre-trained with potentially unsupervised data. Whenever we have to use them for a particular task, there's a configurator that probably needs to properly reparameterize dynamically all these different modules in order to maximize the success for a particular, right? This architecture is very generic. Most of these pieces are already in existing agents. The agents that we see today in the real world, especially those that are in the physical world, they definitely have a critic telling them, trying to evaluate if the plan that is about to be executed is good or not. We definitely have a model of the world. We are trying to predict how different entities around us are going to behave. We have perception, we have memory, The only thing that we might not have is a configurator, but you know, it will probably come soon as this system gets more generic. Now, another definition for agent, but it's a little bit more 2024, a little bit more realistic and grounded, is the one by Andrew and G, which is agent is basically a system that can leverage LLMs or multimodal models as their execution engine, and includes, you know, a memory, can perform some level of planning, you know, can divide tasks or decompose tasks into subtasks, probably can operate iteratively versus your typical zero-shot, is able to call some tools or even to generate some tools, can do a little bit of reflection, also self-improvement. Basically, if you query the model to see what's wrong with the answer, it's able to reflect upon it and say, oh yeah, I made a mistake here, let me fix it. Is able to collaborate with other agents to create more elaborate solutions. Yeah, so this is a more like practical definition of what an agent is to produce and the properties an agent is to have. So why don't we check very quickly on these definitions? And by the way, if you're interested in this, there's an amazing, short but amazing talk by Andrew and G that you can find at this QR code. I think he gave it to Sequoia a few months ago. Okay, first, reflection. What is reflection? Reflection, we have all seen reflection, I think, these days. You can do reflection with ChatGPT and pretty much any other model with Llama, etc. So reflection is when you ask your model to basically self-correct, right? So for example, find all the vehicles in the image, you get an output that involves a few vehicles, but you realize that that's wrong. So you can ask the model to basically go check it out and probably fix it. You know, reflection tends to work well. I have seen cases, especially in code generation, where with a little bit of reflection, copy and pasting an error here and there, you get to have something working. So a little bit of iteration, things end up improving quite significantly. Now, the direction that we are going into is the direction where agents themselves can do reflection without you needing to intervene. And this typically will be a critic model. So basically a different agent that is telling your agent, hey, let me check that out. You made a mistake here. Go and fix it. And this is very useful because this basically avoids the intervention of the user, right? We can maximize the automation of certain tedious tasks this way. Reflection is one of those tools that once you try it, you realize that the power of the tool is immense. So with a little bit of reflection, you can go very far. If you haven't tried it out, go ahead, try it out. You will be quite surprised. The second thing that is important for agents is to be able to access existing tools, right? So we don't have to reinvent a bunch of the stuff that has been created in the past few years, right? We have access to search engines, we have access to calculators, computer vision models, text-to-speech, etc. So I think one of the key elements for an agentic workflow is to be able to access existing tools, or even to be able to create new tools on demand. Like, hey, there's no tools for this, but I can write some Python code to try to solve it. And I can run it and check if it's solved. I can have a critic checking if my code actually solved the problem or not. And I can try to maybe create a different code if this doesn't work. So to be able to actually use tools has made LLMs at least 10 times more effective. Most of today's platforms that are offered to developers are a combination of these two elements, reflection and tool use. And you can go very far away with that if you have access to the right tools. Right now, what we see is these platforms like kind of bootstrapping tooling left and right. connecting to all your favorite systems so that you can do things like, oh, I want to send an email based on this PowerPoint to all my customers, and they will connect to your email service, etc. So all of that is happening as we speak, and in the near future, early 2025, we can expect to see a bunch of those applications out there for users.
So Germán, just until here, until this step that you have been describing, is it reasonable to think that an organization having access only to open source software can get somewhere far in reflection and tool use?
Yeah, very far, extremely far. Yes. You can and you have plenty of APIs that you can use for that. Today, for example, I will be talking about that later, like the Hugging Face Agent API, LangChain. Like there are a bunch of APIs that you can use today to create simple agents that make use of reflection and tool use. And as you need, you can keep adding more and more tools. Even for users that are a little bit savvy, I'm gonna show an example later on how you can even create your own tools invoking LLMs and say, hey, I need a tool to count citations for papers using Google Scholars. And you do that for me, and then go to archive, find the 10 top-cited papers using this tool.
So we don't need to be you guys. We can be just some guys. That's good to know.
That's the whole point. Like eventually everyone will have access to this, and all institutions are going to be able to deploy complex agents with access to very sophisticated tools. So iterative planning is the third element, and this is the big game changer. This is something that is a little bit more modern. So you don't see this yet in many applications. I'm going to show you a few places that have this implemented. This really can help significantly to come up with results where tasks are too complex. So what this is going to try is basically to create a sequence of potential options and tasks. Some of those tasks are going to be optional. Some of those tasks are going to serve as a backup. So in a simple workflow, you can imagine like a basic decomposition of the task. For example, I ask you, what's the sum of 5 plus 7 times 2? A simple way to do this would be through creating a plan that is based on chain of thoughts. So you can invoke chain of thoughts to ask the model to basically reason step by step and do a little bit of planning. This is your most basic form of planning, right? So, for example, in this case, there will be the first step where I have to perform the multiplication before the sum. I know this. Step 2, let me actually execute the task. Then let me remind myself that now it's time to add 5, and here you have the answer. This is the most basic way of doing plan, the chain of thoughts. This is something that you can do today in ChatGPT. There are more advanced ways to do this. Example here, I hope you can all see this. This is Hugging GPT, and this is a platform that is showing like advanced planning. In this case, for an input task, for example, please generate an image where a girl is reading a book and her pose is the same as the boy in the image provided example.jpg. Then please describe the new image with your voice. This is a very complex task. If you try to do this in one go, these things are going to fail. So first thing is the agent needs to divide this into subtasks. So for example, subtasks to do pose control, subtasks to do image classification, image to text, pose to image, etc. So we need a bunch of tasks that then for which we need to find their suitable tools. Some of these tasks actually require tools, so we need to find from a database of tools what is available. Sometimes we might have to generate new tools for a particular task. And sometimes we might need backups for a task because sometimes it doesn't work. The tool is not able to produce the desired result. And we need this task planner to know about this and produce new tasks to try to compensate for errors. Then there's an engine that is going to be executing this task. And the planning is dynamic. So if something fails, as I mentioned, we need to compensate, we need to correct. So task planning is not something that happens just at the beginning of the execution. It's a dynamic component that has to happen throughout the execution. So you need this introspection capability that is checking when certain tasks fail in case you need to relaunch. And this is one of the most powerful elements that is coming to agents in 2025. So we have some examples I'm going to be showing, like for example, Microsoft GPT, aka Jarvis, and some others that attempt to do this. Any questions about planning? Okay.
I understand, Germán, that the LLM do all these tasks and predict all that stuff without your intervention. No, it's alone.
Correct. Correct.
No.
Sometimes
So
that's correct. So typically it does it with sometimes it might ask for help, like, hey, can you help me with this? I found a problem with and we will see that in a few minutes when I move to the demos. Like sometimes you might be queried to provide help, like, hey, I try doing this task using these tools, it didn't work. Do you have a suggestion? Do you have an alternative? But typically it tries to do all of this without your intervention. Any other questions? Okay. And finally, collaboration. So collaboration is a new superpower, right? That makes outputs way more accurate. Why? Well, typically because your different agents can specialize in subtasks. And this is good because they can have their own context window, right? They don't have to share a context window. They don't have to share tokens among each other. They can basically use their full capacity on one task. So many studies have shown that the specialization of agents using a collaborative approach increase accuracy of the system by at least 30%. So you will see that many modern agentic workflows have the collaborative capabilities, so you can invoke different agents to take care of different roles. There's a nice example that I'm not going to show here, but you have probably seen around about an agentic workflow that simulates a software production company, and you have different agents in different roles. So you have product managers, you have software engineers, code reviewers, quality analysis, and you end up having all those agents interacting for hours until they finally come up with a software product. So I think there is a question in the chat.
you have some question in the chat. I can read for you, or are you reading it?
Yeah, that would be great.
Angela is asking for, there are many agentic frameworks like LangChain, AutoGen, Q. Which one do you recommend to connect with open source models? This is the first question.
Depends. It depends. If you are a developer and you feel comfortable, developing your own solutions and playing with that, I would recommend like accessing LangChain through potentially the Hugging Face API, the Hugging Face agent API.
LangChain, no? Better than AutoGen.
Yes.
Okay, second question is that
if you're not a developer, you probably have to wait.
the tool calling part sometimes is unstable. For example, they may get lost and get into a loop. Do you have any suggestion for that?
No. So that's one of the problems today. Like integration between the LLM engine and tool handling is still not very stable. So when it works, it can produce things that are fantastic. But when it doesn't work, it can get very tedious. You wait a long time for an answer. We hear, hey, it didn't work. What should I do now? Model needs to be able to become better with more training on tool handling. Tool handling is something that is still in the early days, right? And it's all a matter of better integration and making sure that we can fine tune our LLM engines to handle these situations in a better way. Add more iterations, have more backup strategies when a tool fails. So we will see more of this coming. Like I know that so far is if you have played with these agentic workflows, it's a little bit frustrating, but these things are maturing, and we will see very soon agentic workflows that are better handling tools and manipulating what we call like situations of like failure points. The management of failure points will keep improving.
Okay, there is the third question is there any recommended way to evaluate the consistency of the generated agents' outputs? How to benchmark everything?
Probably the best thing that we can do today is to make use of one of the existing public benchmark, like the Google benchmark, Google GPT, etc. Of course, if you have an application in mind, you can attempt to create a small benchmark for that application and check for consistency. Sometimes these public benchmark are a little bit generic, right? And you end up getting amazing accuracy, but it has nothing to do with the type of task that you have in mind. So it becomes a little bit disappointing. So if you have something in mind, potentially just go ahead, create a few example use cases and try to run variation of those use cases in your agentic workflow to check for discrepancies and performance.
See, thanks, Andrew, and that's all the question. Thank you.
Okay. Why don't we see a few demos? I mean, this is gonna be a little bit in the wild, so let's keep our expectations moderate. I'm gonna start with Agent GPT to see what some of these things can do. So this is Agent GPT. Agent GPT is not multimodal, but still we can attempt to do interesting things. So for example, let's see, find for me the top archive papers in the area of agentic AI and summarize it. Okay. Let's see where this goes. Oops, sorry. Okay, you can start seeing here some of the steps that I mentioned before. So it's trying to do planning. So from the initial task is decomposing things into subtasks. So that's how the search archive for papers in the area of agentic AI. That's how retrieve the top papers, extract the summary of abstract of the papers, provide the summarized abstract. And then it's starting to execute this task. The first one, search archive for papers in the area of agentic AI. Some of these tasks are gonna end up rejected, like not used at all, in my experience. Sometimes some of these tasks are gonna produce very useful results, but they are not gonna make it to the final answer. So it's still messy. So finished search of archive papers in the area of agentic AI. It has actually produced a few papers. Track and summarize the content of the top archive papers in the area of agentic AI. Okay, did this well, so, or I'm assuming it did it well, because I'm not gonna go in and read this paper. It's providing a short summary. It added another task to create the abstract, but you can see that this task is redundant because the previous task already did that. But it can happen that sometimes you plan for things that are redundant just in case the other task fails. And the outcome is different. So the actual abstract here is a little bit longer. And here you see that we got the final answer as a combination of the previous task. Now, out of the, sorry, this is still trying to provide a summary of the abstract. This is getting into a little bit of a loop. You can see this has been executed a few times. Question is if at the end we're going to get the papers or not. So a few things that we observe in this example. Okay. By the way, I have executed similar examples around like 20 times. My accuracy with this example is probably around 25 to 30%. It works 1/4 of the time. What typically happens here is that the planner gets a little bit crazy. You know, there are moments where all the information is there. You know, you have your abstracts, you have your papers. It found the papers on archive, so it did the task of going out and search the website well. It was able to do the summary, but you know, is not able to understand when to stop the task. That actually it has reached a point of success and it's ready to basically summarize the information. The planner goes a little bit crazy. When it works, it's great, but it doesn't always work. It's a very experimental platform. So let me show you another platform. In case you care about your code, this is anything LLM. And I like a lot anything LLM because it really connects to many different type of models and workflows, both online and locally. So it gets you access to Olama so that you can actually run some of these models locally without having to connect to a cloud service. This basically saves you time and money. You can activate the agentic mode just by typing agent. Okay, let's do a quick search. So can you find about okay. A little bit more complex. Abstract, affiliation. is finishing the first part of the task. I take a little bit. This is running. This is actually running on the server.
So Germán, one stupid question. You just said that one of the problems it had was that it never really knew when to stop the task, when to stop trying to get it better and better. Is it possible to kind of pre-program or limit its use of energy? Or, I mean, because you see living organisms or humans would they might have a clear role, a clear goal, sorry, and then they actually know very well when a task is completed, or they do this thing that machines don't do. They call it a day and decide that they are tired, and this is where they got. Is this something that you can tell a model like this?
Actually, many platforms do that, and that's probably not the best solution. It's a very
Okay.
frustrating solution. We'll see that in another example, where they just call it a day and say, look, this is too hard. I've tried. I have consumed my allocated cycles. And if you have suggestions, tell me about it, but I'm going to call it a day. What we need is a better critic. So we need this agent that is able to supervise our agent to say, look, you have already found a solution here. This thing that you have produced is good enough. Go ahead, present it. Like you might be able to have a better solution in 5 more minutes, but keep these as a backup and present it if you don't find anything better. Versus just say, okay, I have run out of cycles, I have exceeded this amount of tokens, let me call it a day. So we need better critic strategies. And I'm pretty sure that these ones are coming too.
And how are you guys going to get them? Those better critic strategies.
You need to train those critics. So you basically
I
need
see.
to fine-tune models to become better critics.
Great.
So right now, critics are very generic. Take your vanilla LLM and try to use it as a critic. So we need a little bit of a specialization for that job.
That's what I was thinking. So like training the critics into to perform in niches, perhaps, right? or in specialized data sets.
Yes, they need to specialize in the task of being a good critic or handling tools. Like when they are presented with the task of, there's this agent that has been handling tools and calling tools for this particular task. I need to, as a critic, I need to be able to assess if one of the outcomes is actually successful, and I'm going to be able to provide enough feedback so that somehow I route one of the solutions all the way down to the final answer. So we need critics that have higher cognition capability, not just like this is wrong, this is good. Critics should be able to plan as well. Critics should be fully agentic workflows that are able to plan and say, hey, if I am presented with a solution, depending on the quality, I might tell the agent that produced this result to keep it as a backup or just to discard it and try again. We need critics with those capabilities.
So you're describing a community of artificial agents in a sense.
Yes, a community of artificial agents. And we will see in a minute something that is attempting to do that, Hugging GPT. Okay, but just to conclude this silly example, you can see basically the agent was able to come up with a solution to the task or for a few papers, telling me the name of the authors, affiliations when clearly available. Sometimes I'm trusting that this information is correct, but we should probably have a critic checking this out, abstract, etc. So you see, Anything element is a great app for your desktop if you are willing to basically come up with some of your own tools. So far, it has 10 tools available, including web search, etc. The community is creating more tools that you can download. You can write your own tools using JavaScript. You know, eventually, when this gets a little bit bigger, I anticipate it's going to be very, very useful, especially with the capability of running models locally. But so far, it's a little bit limited. Other examples. This is one of my favorite. This is Vision Agent. This is by Andrew Ng. This is one of the startups of Andrew Ng. And basically, this one is multimodal. Okay. It is specialized in vision and text, basically images, videos, etc. It presents some of the problems with other agents. This one actually asks a lot for help. Let me show you some of the examples that I have been working on. Like this is a case where I asked just track the skater in the video. Okay, simple video. There's a skater ice skating. This example works sometimes. The first time I tried to solve the problem, the system was able to come up with a very good tracking. The second time that I tried to solve the problem, the system started complaining and say, hey, it's not a consideration for tracking, the skater in the video, timeout. Let's try a different approach by breaking down the task, blah, blah, blah. I didn't continue because actually, when I attempted to continue, it produced results that were not very satisfactory. So it just, in this example, I just let it be as it is. This is a failure case. But as you can see here, actually the agent gives up and say, sorry, I thought I could finish the problem with this approach. I cannot. Are you fine if I try a different approach? Say, no, don't waste my money. Thank you. This is another example. Can you track both people and sharks in the video? Save a video with the track mask of both sharks and people and draw a line between the shark and the closest person with the distance about it. Use 13 pixels as 1 meter and samples at 10 frames per second. And you can see here something interesting that is going to be generating code. It's going to be generating code that is going to execute to use as a tool. This is one of those advanced capabilities where you don't have just like a bunch of models trying to produce the different outcomes. You have a planner that as part of its plan is writing code. And then it's executing the code and collecting the results. This is the final result. I will say it's not bad, but it didn't do everything we asked. We asked for a line connecting the closest person and the shark. It did well by tracking people, etc., but it didn't fully solve the task. Probably with a little bit of work, we can make this improved, etc. But so far, it didn't produce the expected result. Let's go to see another platform. By the way, probably Vision Agent is one of the most advanced vision and language platforms that we have today. It's not perfect, but it's evolving quickly. And I anticipate that in 2025, it's going to be a platform that all of us can use successfully for this type of use cases that involve, multimodality. This is another, oops. Of course, having this have to break now. This is what happens when you deal with state-of-the-art stuff. This was one of the coolest examples, actually, that was working until an hour ago. I'm always having a runtime error. think they changed one of the modules. And now it's crashing. I will just describe it for you quickly. But this is Hugging GPT. Maybe there's another space with this. All of them are crashing. Well, let me just show it to you. This is something that you can run locally if you want to clone it. It's a very cool. This is the slide I showed you before. It can do pretty cool multimodal things, like for example, finding poses, generating images, analyzing audio and video. And what it's doing basically is to access models from the Hugging Face ecosystem. So if there is a model in Hugging Face to do text-to-speech, audio analysis, generation of images, etc., the tool has access to all those models. So as it's doing the planning, it's going to try to find a model that can be used to solve a particular step. And then it's just basically executing all those models in Hugging Face and bring out the outcomes and composing a solution. This is great when it works. I have a very cool demo prepared for this. Sorry about that, but when this is up again, I recommend you to go and play with it because it's pretty impressive. This is what we can expect to come to our, user interfaces in 2025, like a pure multimodal model agent that can do this type of complex planning, get access to a huge ecosystem of models, and work for us to find a solution. And if you are a developer, you can get access to the creation of your own agent architecture or your own agent framework today through the Hugging Face API. So Hugging Face puts in the hands of every developer a reactive multi-step agent, okay, with a very simple interface where you can call existing tools in Python or as an API remotely, etc. Basically, through a very simple API, as I mentioned, just agent.run, specify the task, and then you can also specify the tools that are available to the agent, etc. So I would recommend you take a look at this website if you're interested. If you haven't played with the Hugging Face agentic interface, if you know a little bit of Python, this is a great starting point, and you can come up with some very complex workflows in a few lines of code. So yeah, pity that we lost the last demo, but I think I'm gonna end here, and probably we can move to more questions and we can just wrap it up. Questions? As you can see, agents are about to land. Sometimes they work, sometimes they don't work. When they work, they're amazing, but they're still like on the cutting edge. You typically bleed when you touch them too often. When I was preparing this presentation, they were wonderfully this morning when I tested, they were working with my APIs, etc. And then last minute, like boom, some of them start failing. That tells you a lot about the current state. So they are in a state where developers can use them and put things together for users, but still not ready for prime time for users, for end users. But it will be happening in early 2025, I promise. Questions?
Can I ask one? Okay, thank you very much, Germán. This was absolutely fascinating. I have a relatively simple question just out of curiosity. What's the architecture for connecting tools? Because like current ChatGPT, for instance, doesn't make mistakes when it comes to calculations. So I'm pretty sure it has an external calculator attached to it somewhere. And but this is reliable. So this doesn't fail and go into endless loops. So is there a difference between these sort of relatively fixed kinds of tools that the model can basically be pre-trained to have access to, and the more complex ones that you described with the planning, where you need a planner or configurator, basically?
Yeah, so basically there are solutions like ChatGPT uses today where there's a very well established set of tools. Like you have a calculator, maybe you have web search, you add it as a plugin. It's not going to try fancier things. You're not going to try to come up or imagine what tools could be used on the go. So when you have something that is so prefixed and static, it's very easy to know, okay, I have a multiplication in my query. I know I have to call the calculator, which is one of the well-known tools. The problem is when you have a task that is way more complex and the agent is trying to come up with potential tools that could be used in runtime. Sometimes it fails, especially when the agent is actually creating the tools on the go. Like, I don't have a tool for cropping the image, but I can create a Python script to crop the image and now use it as a tool, as one of the agents was trying to do. Well, it's the difference between a very static architecture and an architecture that is way more dynamic, where the agent is coming with an iterative plan, tooling, etc. Then things can fail.
But that means, on the other hand, for our relatively static tool set at the multidata pipeline, we could basically envisage a natural language interface for people to describe what they want and then configure the which tools to use out of the set of like 7 tools or something like that that are currently in there.
Absolutely, absolutely. So for your particular case, if you actually are fully aware of the task that the user are going to be, trying to solve, it's much more practical to take a fixed agent that has a bunch of steps that are well known, using, for example, the Hugging Face API with LangChain, etc., and accessing the ecosystem of models that already exist in Hugging Face.
Okay, thank you very much.
You should write an Erasmus Plus project on that, Peter.
Not impossible.
You can go very far away with the Hugging Face agentic API today. It's super easy to use. It has access to a plethora of models. Everyone is uploading their models to Hugging Face. Many of them have very permissive licenses.
Don't forget, Germán, we're in Europe, and Europe and data protection usually tells our data protection people tell us we usually shouldn't use these cloud services hosted somewhere in the US or in China or where you name it. So that's why I think Cristobal asked for open source tools. Basically, we need to be able to deploy them on our service in order for this to be in compliance with our regulations when it comes to data processing, at least for many like lab recordings and things like that.
That's great. An alternative then that is very interesting, in my opinion, is NVIDIA NIM, which basically is something that you can run locally. You can basically ask for the Docker container, run locally. You can fine-tune or retrain with your own data if needed. You can set up the same agentic interface using all the other APIs. The Hugging Face API, one of the good things, like not just to call like external services, you can also use it to invoke local models.
That sounds really interesting. So I'm going to take a look at NVIDIA NIM and we'll see whether we find an easy way to deploy it here. Thank you.
Germán, I have a very social question. What you have here is to a great extent people coming from the humanities and social sciences. They're studying language, they're studying cognition, they're studying the processes that allow humans to get meaning out of multimodal stimuli. and interact with them constantly and produce very complex meanings. So, and they want to get really, really, they have really challenging tasks and really challenging things they want to get out of the data. They want to reconstruct gesture trajectories. They want to reconstruct prosody structures that go with the gesture trajectories, plus interaction with objects in the environment, plus alignment of humans when they are communicating, and so on and so forth, gaze, etc. So the chances that they're going to do those things without technology are pretty much the same chances that physicists have of doing anything without computers. So it's not that we always realize it, but that is the case. Now the big deal now is to have a way of productively interacting with the ecosystem you just described, because it's a lot. It's a lot of different systems, a lot of tools, a lot of opportunities, and it's changing in a matter of hours, as you just described. So we know nobody has the Holy Grail, but there is this huge community of people who want to engage in a two-way street. So like they have two main questions. One is how do I get the best tools for what I want to do? And the second question is, how do I get to engage with the people making these tools so that I can help them make them better? Do you have any tips to this community? Because I'm not asking you for a full-fledged plan or for the Holy Grail, but do you have any tips of advice to help us move forward a little bit?
I think. Well, first of all, you are not in a special position because sometimes you actually know what your user are asking for, in the sense like they have specific workflows that they want to execute. In that case, there are platforms that can help you today to establish that workflow. Right. For example, let me show you something real quick. This is something that I didn't present because it wasn't a user-centric platform, it's a developer-centric platform. But here, if you know your workflow, you can predefine your workflow here, like using different AI tools. For example, if you know that you're going to be calling, if you want to do an embedding of an image, you can call an embedder. If you know that you want to have a memory, you can add a memory module. If you know that, for example, you want to use OpenAI capabilities for text to voice, you can basically add it as a node. So one simple way to operate when you know a little bit the tasks that your users are going to ask for is basically to use this type of platforms to create specific workflows or the Hugging Face APIs. If what you want to do is to get access to a generic agentic workflow that basically is able to answer any potential queries, you probably have to become part of the community of one of the platforms that I have presented before, and just be very active and participate. Like, give your feedback. Like the best thing that these platforms are all emerging. They're typically small startups behind this that have taken VC money. And the best thing that they can get today is power users that are using the platforms and providing feedback, saying, this doesn't work. I need help with this particular module. I would love to have this task, and I will be willing to, maybe pay for a subscription. So joining the wagon of these new agentic platforms and be a power user that provide feedbacks is probably one of the best things you can use if you want to leverage like a very easy, ready to go applications. If you have a team of developers that is willing to put together workflows that work for you, and you are clear on what your goals are, having those developers putting together like a static framework with multiple steps, invoking different agents is a good solution. I hope this helps with your question. I know it didn't answer your question, but I hope it helps.
I think it does. I mean, this is a question we're going to be answering for a while, I think, but we
It's
need
gonna take
things
time,
like
yeah.
this. Yeah. Okay, do we have any more questions for Germán? Then, Raul, do you want to wrap this up?
No, I really only want to say thanks to Germán. The talk has been really interesting. I have taken a lot of notes. I will maybe send you some mail to ask you little question about how to take the path to try all these tools and this agentic workflow. But we have to work in this because I think this is the future. This is what we are going to be using next year and the next year. So we are on the path. And just say thanks to Germán. I don't know if anyone want to say anything else. You want to just
Thank you very much
talk.
Thank you very much for all of you to be here today, for the invitation. I hope that this gives you sort of like an insight into what is coming. It's still thin edge, it's still breaking, but it has a lot of power and it's showing a lot of promise. So stay tuned for more. And thank you.
Thank you so much.
Thank you so much, Germán. Stay tuned, subscribe to the newsletter. Thank you all very much.